Okay, welcome everybody. Today we will be going through two exercises and it'll be us just polishing off the unit. We won't do all of the questions, I'll be very specific about what I want you to do. So we're starting with 4G, which is definite integrals. And what you'll see pop up here, the difference is, previously we've integrated, we haven't had any numbers written here, we've just had the integral of f of x. With a definite integral, it gives you the boundary. We have a lower boundary and an upper boundary. And to begin this lesson, we're just going to evaluate them. And then a bit later, we'll start to talk about what the significance of this boundary means, leading into the applications of integration. So this here is what we call the fundamental theorem of calculus. Okay, so there's 3 steps. And this is really the basis for your folio. You're going to be using this a fair bit in your assignment that you'll get in a couple of weeks. And let's get straight into the example for it. So we're asked the definite integral from 0 to 2 of the function 5x to the power of 3. So all we're going to do is integrate it. Okay, when we integrate f of x, it becomes capital F of x. So the 5 hangs out. Integral of x to the power of 3, we're just using the power rule. That's going to be x to the 4 on top of 4. And the boundary we have is from 0 to 2. Okay, so far we've moved from here to here. All right, we're at the second step. Okay, so then for the third step, all we're doing is substituting the upper boundary in, take away, and then we substitute the lower boundary in. So when I substitute the upper boundary into here, I'm going to have 2 to the power of 4 on top of 4. All right, so I'm putting the upper boundary where the x's are, and then when I put the lower boundary in, we're just going to have 0. Okay, this component's evaluating to 0. Here we have 2 to the power of 4, which is 16. 16 divided by 4 is 4, and 5 times 4 is 20. Okay, so there are basically, what steps do we need? We've got the question. Here's the first step, the integral statement. Then we have the substitution. We need to show the substitution. Now, it is acceptable, all right, to put that part there. And here you can just write 0 because you can see that that term evaluates to 0. It won't always. When you're substituting 0 in, it won't always go to 0, but in this circumstance, we can see that it does. And then your answer. So there's sort of 3 components required to show full working for definite integrals. Now, in a moment, I'm going to show you some syntax for which we can just type that straight into our calculator and confirm that this is the answer. Okay, we'll get into our second example here. Applying the same rules, the integral of e to the 2x is half e to the 2x from 0 to ln3. Now, when we sub in ln3, so we do the upper boundary, take away the lower boundary. That'll be 2 times 0. Okay, and we're going to try and simplify this. All right, so here's when I've substituted, I'll put it in brackets now so we can see them as separate. The upper boundary, take away the lower boundary. Now, if we're going to simplify this, I'm looking at that and going, I've got e to the logarithm. We know that e to the ln a simplifies to a, so I need to try and express it as a single logarithm, and I'm going to do that by moving the 2 to become a power. So we'll have half e to the ln3 squared, or ln9, right? And over here we have half e to the 0. All right, so this e to the ln3 squared is going to simplify to 3 squared. The half is staying there. And 3 squared is 9. So that's what's going on. It becomes half of 9. And then e to the power of 0 is just 1. So that just becomes half. And so we've got 9 on 2, take 1 on 2. That's going to be 8 on 2, which is 4. Okay, so we'll try a few questions, but I'll just show you how you can type this into your calculator quickly. What we do is we press Option. So we're in Run Mat in the basic mode, just in where you perform all your calculations. We press Option, Calc. We'll press the across arrow. Sorry, we don't press the across arrow. We have Option, Calc, and you can see at F4 we have the integral of dx. Now we're going to press that and we can just type in exactly what we have here. So if I type in 5x to the 3 is my function, my lower boundary is 0, my upper boundary is 2, and then evaluate it, I get 20. So we can see that that will be our answer. Okay, so let's get you guys to just have a little bit of a practice first with question 5. So 4G, let's just go straight to question 5. All right, you can do the other ones a bit later if you want to. I don't think it's necessary. Just start with question 5. Those skills, let's spend about 20 minutes cranking through those.